Okay. All right, well, let's practice. Let's work one more through to see if we can help people that are having their existential crisis Friday instead of Thursday. Because the data isn't just nice and pure and easy. So please listen. What I'm looking for somewhere where one is held constant and the other one changes. So that these two fit that. Are you okay with that? So my eyes are just looking for where something's the same twice in a row and then something else isn't. Since this is held constant, it's going to tell me what happens to y. Because x is the constant. You all right with that so far? Everybody? Bisky? Okay. So looking at these two sets of data, I chose them because, once again, constant and doubled. So from 20 to 40, and I know it's 0.2, but whatever, that's twice the concentration. I look at the rate, and what does it do? It doubles. And if you don't know how to figure that out, just take the bigger number and divide it by the smaller number, and you'll get a 2. All right? So that will tell you right now that y, if you put a 2 in here, the answer becomes a 2. So that means y is raised to the first power. Did that make sense? Raise your hands if that made 100% sense. Okay. Don't give up, Murray. Just keep looking. And hopefully it will make sense. Okay. Now, Emily, what were you mad at? Y never stays constant. What? So we just give up? Is that what you said? All right. Okay, we know something about y. So let's just look here. So we're now trying to find the exponent of x, correct? All right. And I know when y doubles, my answer should double, correct? All right. So this answer should at least be 2x, and that came from the y value. Look here. When this doubles, what happens to this rate? Okay. The rate doubled, right? But that was because of y. Did it do anything more than double? No. That means that whatever I put in for x, nothing happens. So what exponent causes nothing to happen? 0. An atomic bomb.
0 equals 1. It's the atomic bomb.
Okay. Sorry. That sounds super inappropriate. Which is exactly what I would expect from Parker. All right. Raise your hands if what I just did the second part made perfect sense. 1, 2. Is that a full hand or a half? 1, 2.5. Now I got to count half. Hold on. I'll count you last. Raise them again. 1, 2, 3, 4, 5, 6. Okay. Now we're at 7. What is that? 7.5. 8. We are at a whole number. We are at 9. All right. We're good. Just kidding. That's not acceptable. We should probably just keep doing a couple of these. So, FYI, it is absolutely possible that we have something that its concentration does not affect the rate. If I take magnesium and I add it to HCl, a reaction will happen. If I change the concentration of HCl, the reaction happens faster. I can't really even change the concentration of a solid. I can put more of it in, but it's just a chunk of stuff, right? So if magnesium were in this we would raise it to a 0, and we would only care about HCl. Well, we can like powder it in something, but that's not what we're doing here. We're trying to change the concentration of the thing. But that's true. We can heat it too, but that's not what we're talking about. Okay, now that you know the rate law equals K, this will annoy math people. The equation's written this direction. Will you try and find the rate constant? So rate equals K, x0, y to the first. These are actually really nice. Do you know why? Yeah, the x goes away. It's a 1. And I love 1s in math. Unless it's the square root of -1. And then that becomes I. And I hated i's. I don't think we should have to learn math that doesn't actually exist. Pun intended.
I agree that we should be able to pick like what if we know what we want to do in the future, like by sophomore year, that we don't have to take all our general classes.
What would you like to?
Take part in our classes. Like, why?
I know, and it'd be like,
All right. So I'm just gonna say K equals rate divided by, ignore that arrow. Was it Y? Is that the one that was a 1?
Yeah.
Y to the first. So K equals rate. We just choose whichever of the 4 we want. I always choose the top one. So 0.0. No. Yeah. Because that's not the answer yet.
oh, okay.
You have little faith. All right, and then we divide it by 0.1, which now will give me. All right, what is our unit? Shh. Here's the unit. Are we ready? So the rate was measured in molarity seconds. Are you okay with that? Yeah. All right, so I'm going to, I'll write it in red. So I got molarity seconds on the bottom. And then Y was just measured in molarity, correct? So now I have molarity. Oh, no, I don't. I have molarity, but obviously what happens to those? They cross out. So the unit is just really 0.00 s to the -1.
Sorry.
You're fine.
No, I thought.
Yeah, it's all right. We're good. We need one of those like wrestling referee noodles.
It's like a thing. Like,
So they know that the time's up.
If you know the rep, you're like, okay, I'm gonna hit something.
So take a couple minutes and see if you can pull this all off. All right, I added that 4th line so you could solve for x. I mostly said that for anyone watching this video in the future. So here we go. The first thing you do is you try to identify when things are held the same and when one part's changed. In experiments 1 and 3, NO is held constant with 0.01 and 0.01. So we want to look at these two, whoops, not these two. Oh, come on. These two rates, and from 2.5 to 5, that is definitely a double, correct? So we now know the exponent of O2 is it is a 1. What? I'm struggling, and I don't mean to be rude, but I don't know how you don't get it by now. That's rude, huh? Like, I'm not. If I go from 0.01 to 0.02, math says I have multiplied that number by 2. If I come over here and the rate is also multiplied by 2, then whatever number I put here, if it is the same number here, then the exponent has to be a 1.
Alright, okay, now that makes sense.
Oh, I think I just bullied you into saying that. And you're not alone. I don't know what I'm doing wrong this year. How's that? Because this usually goes quick. All right, now I'm going to erase that so we can find the other one. So this one was easier because these two right here were held constant. They were right on top of each other. And you will see here, point 1 to point 2 is multiplied by 2x. All right, or multiplied by 2, whatever. Then you come down here, and this is not just doubled anymore. What is that? That is 4 times. So you would have a number in here. You doubled that number, but the math answer said it was a 4. So the only way 2 can become a 4 is if you square. This whole job, this whole activity is to find these exponents based on math. So that would mean now your rate law would be defined as rate equals K. I did O2 first. That was raised to the first. And then it was the NO. NO, and it was raised to the second. So that would be a correctly stated rate law for full credit right there. The next part of the problem was to solve for K. So K is equal to rate. I'm just doing the algebra. I'm taking these two parts under over here. So O2 to the first. I'm not going to bother writing it. I will just in case, I guess. And NO to the second. And then I find the information to plug into these on any of the row I feel like putting in. Any of them would work. So this one, I always pretty much pick the top row. I like it also because there's lots of 1s in there. So both of these are 0.1, so that'll be easy. So K now equals my rate. I forgot to look. All right. Thank you. 2.5 times 10 to the negative fifth divided by, was it 0.01 or 0.001?
0.01.
All right, and one of them is raised to the first, and one of them is raised to the second. And then I just type that into my calculator, and I have no idea. Is it 0.025? What's the answer? Oh, sweet. That's a lot more zeros on the bottom than I did in my head. 25. That's a nice value. I like that number. All right. What's that? Yeah, interesting. This was probably the 25th anniversary of the AP test.
So every answer's
That'd be amazing. All right. Now, yeah, it would.
25. What do I do?
So here we go. Now the units. The units, I'm sure, were still molarity seconds, and yeah, they are, and molarity. All right, so K is equal to, I'm just taking every part of every unit. It was molarity second. That takes care of your rate. And then on the bottom, you had molarity cubed, because you had molarity to the first and molarity there. So really, one of these can cancel out, correct? So you end up with the unit being S to the negative 1, molarity to the negative 2.
What was the point of example 4?
We haven't done it yet. So, experiment 4, that's okay. Experiment 4, we're now trying to solve for this. So we rewrite our rate law solving for O2. I'm going to erase this part. Is that okay? So now I'm going to erase that part too. I'm going to go right to the original one. So O2 will be equal, algebraically, it's equal to rate divided by NO and K. Are we all right with that? So I'm going to rewrite it. O2 is equal to rate divided by K times NO squared, right? So I just took these parts of the rate law and redid the algebra. This would be the concentration. And then I take the values from the fourth row and I put it in. So 5.3, I've erased that. What was that? Was it 10 to the negative fifth? Okay. And I divide that by K, which we said was 25 times the NO concentration I gave you was 0.03. And that's squared, correct? Because of the rate, it's right there. And then that will be equal to some magical number that's probably not a whole number. What do we end up with? All right, and that would be molarity. You what?
Did it right.
Yeah, I feel like
I just flung numbers in the right pattern.
So at my house, this is pretty random, but at my house twice now I've walked into my kitchen and I found a wedding invitation. It's just like a one piece of cardstock thick thing, you know, and I read it, and then we have a shelf where we put stuff. And twice now I've taken it and I've thrown that piece of paper and it's like curved and it's gone straight into the shelf. Twice. Just boom. No, like into the shelf, standing on its side, right where I aimed it. I've done it twice. Does that mean I know how to do it? No, I'd say I got lucky 2 times. Some of you just said, I did this, but I have no idea how I got it all right. You're throwing the wedding invitation, and it went where you wanted it, but you don't know how you did it. All right. What homework problem did you try that you could not do? Was that you, Bisky? All right. This is problem number 29. Oh, all the words are gone, but it's the same. Use initial rate data, that's what this is called, to find the rate law, the value of K, the units of K. Sound okay? Okay.
Hi guys.
Hey,
You have an answer now.
forgot to restart that. It was 3.41. Our rate law was rate equals K, BF 3 to the first, and NH 3 to the first. Okay. I don't know. Raise your hands. Give me 5 fingers if you're 100%, 1 if you're sort of pretty much lost.
I think I'm decently.
Okay.
Isn't this supposed to be?
All right. The next part that we're going to talk about. Did I get enough shushes for your grates? All right. If you all are interested, you can use the. Never mind. But you can find out how American you are using an app. Yeah. I am 77% American. No one at the lunch table was above 45% American but me. What it does is it takes the percentages of your 6 generations past you, or before you, of where they are from. And then it tells you what percentages you are. It's pretty cool, but it's the LDS Tools app. and you have to use, it's like an add-in called Grandma's Pie Chart or something like that. It's from BYU. It's pretty cool, but I had no idea I had so many Native American relatives. I knew I had a grandma, great-grandma, that was Native American. Anyway, that came up because you said great-great-great-greats. And I'm like, American, 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 American. Parker is like 10% American. Or was it Bert? Someone at lunch is like, not even American. Donald Trump would probably deport him. Sorry, that's not funny. All right. Integrated rate loss. Here's the good news. We don't actually do the calculus. It was already done for us. Using calculus to integrate the rate law for a first order process gives us this stuff. This equation. That's a naught. That thing's supposed to be down there. And the t is supposed to be down here. So how about I just rewrite it? So negative kt equals the ln of A at some time over the concentration of the time 0, which is also known as the initial concentration. This is only for first order. ln, the natural log. Okay? So, like, don't write it as one giant thing. I just rewrote that half. All right. A naught is the initial concentration of A. I would write this if you have not yet. AT is the concentration of A at some time during the course of the reaction. This is a super nice thing for a chemist to know. It can tell you the exact concentration at specific times. Or, if you need an exact concentration, it will tell you the time that that would happen. As long as you know K, you can do the rest. And it's pretty slick. All right, this is called the integrated rate law for a first order reaction. They are different for second order reactions because a second order reaction has a different equation. So if it has a different equation, the integrated version of that equation will be different. All right. Oh, I thought we had 5 more minutes. We have 15 more seconds. What we can now do, and we'll do this Monday, but if we can find a way to solve for K, which we just did, we can then find concentrations at any time we want.